Hello everyone and welcome back to this channel. In today's video, I'm going to show you how to solve this classic, interesting, but fun projectile motion problem. Let's look at the problem. Two identical balls are released at the same time. One is dropped from rest and the other is launched horizontally 10 meters per second from the same height and at the same time. Which one hits the ground first? This is a very interesting problem and I would like us to read the problem again one at a time. So we have two identical balls. In this case, they are identical because they are of the same size and shape. They are released at the same time from a certain height each. One of the ball is dropped from rest, which is key to solving this problem, and the other is launched horizontally at 10 meters per second from the same height. Which one of these balls is going to hit the ground first, and why is that so? We are to take the acceleration of free fall as 9.8 meters per second squared. Also, in this problem, we are assuming there is no air resistance. Alright, so let's look at the diagram on the right hand side. On the right hand side, we do have a red ball, which is the ball that is dropped because we can see the initial vertical velocity is equal to 0. And then the blue ball, which is given an initial horizontal speed of 10 meters per second. So this v naught x is 10 meters per second. However, it wasn't given any initial vertical speed, v naught y. And based on these two conditions on each of these balls, we are going to find which one hits the ground first, basing our argument on the fact that they are both released at the same time and also from the same height. To solve this problem, I'll first look at the analysis of each of these cases. And then we are going to look at the key concepts that can guide us into solving this problem. So the first thing we have to look for is the first ball. So the first ball is dropped. So this is the ground for the first ball, which is dropped. So being dropped means v naught y equals 0. Because it wasn't tossed either downwards or given any horizontal velocity, the velocity this ball will begin with, or the speed with which it will fall, will start from 0, and then this speed is going to increase until this ball falls or hits the ground, and it will hit the ground with some final velocity, which we don't know right now. The second ball, however, is given from the same height, is given an initial horizontal speed. So in this case, we have the second ball given some initial speed horizontally. And that speed is 10 meters per second. However, the interesting thing we have to note is that due to gravitational pull, each of these objects are affected vertically by the gravitational pull, because we know that acceleration due to gravity acts vertically downwards. So with that will also start this ball with a vertical initial velocity of 0. Now we can see that both balls would have an initial vertical velocities of 0. The difference is that one of the ball, which is the blue ball in this case, is given an initial horizontal speed of 10 meters per second. And then the red ball, which is the first ball, is not given any initial horizontal speed. So in this case, this blue ball is also going to hit the ground with some final velocity, which we don't know. So the key point here is that for the vertical motion, the time it takes for each ball to hit the ground depends only on the vertical motion, since gravity acts downwards. So both balls will start with an initial vertical velocity of 0. So ball A is dropped from rest and ball B is launched horizontally. So its initial vertical velocity, as I just explained, is also 0. Okay? Now, to calculate which object hit the ground first, we need to know what time each of them takes to hit the ground. All right? And from kinematics, we know this equation, delta y equals 1/2 gt squared plus v naught y t. In this case, v naught y is the initial vertical velocity. In both cases, both balls have the same initial vertical velocity, and they are both acted upon by acceleration due to gravity, which is vertical. So we use the same equation to determine what time, or by how much time it would take each of these balls to hit the ground. The one with the shortest time is the one to hit the ground first. So here, we know this delta y is simply the h, the height of this cliff, right? Or whatever height they are dropped from. So we can represent this as h equals 1/2 gt squared. Now our initial vertical speed is 0, so that takes this term all to 0. Now we can isolate the time. So the time is going to be time equals square root of 2 times the height divided by g. And this is the time it will take each of these balls to hit the ground. Very interesting to note that this time only depends on the height from which these balls were dropped. All right. And from the problem, we are told that they are both dropped from the same height and also at the same time. So these are the two key information we need. Acceleration of free fall is just a constant in this equation here. So the determining factor of how long an object will take to fall vertically to hit the ground from a certain height is just the height and the acceleration of free fall at that place. So for example, if this is situated somewhere on the moon, we know the acceleration of free fall on the moon is different from that on the earth. So in that case, the time will vary. This is really cool. Let's look at the horizontal velocity of the blue ball if it really affects the motion. The fact is, the horizontal velocity given to this blue ball does not affect its motion, right? So what we need to note is that gravitational pull always acts vertically. So this initial speed given to this blue ball in the horizontal direction is not affected by the gravitational pull. However, that horizontal speed is going to determine the range from the base of the cliff to where it hits the ground, the range this ball is going to travel. This without any horizontal speed, we could see that it is not going to travel any range. It just travels vertically downwards. So the key point to note here is that it takes the same time for both balls to hit the ground. And this is the physics. So all you need to do is calculate the fall time, okay? Because it is a projectile motion and it consists of two parts or two dimensions of the motion, vertical and horizontal. The only connecting thing between the two parts of this motion is the time. Each part of this motion occurs at the same time. However, you treat the vertical motion separately and also the horizontal motion separately. And in both cases, as in this problem, even though one is given an initial speed in the horizontal direction, it has no effect on the fall time of this object. And that is just the physics behind that. So just as a recap, we now found out that in the absence of air resistance, which in practical terms is not possible because we always have air around, but in this case we are assuming or neglecting air resistance. Again, both balls must be dropped at the same time for them to be able to hit the ground at the same time, and they have to be dropped. None of these balls has to be given any initial speed in the vertical direction. So with that, we can conclude that the time it takes for both balls to hit the ground is simply t equals square root of 2h divided by g. All right, so the higher the h, the higher the height from which both balls were dropped, the longer time it takes for them to hit the ground. Thank you very much for watching this video. If it was useful to you and this is your first time, please like, share, and subscribe to this channel for weekly physics problem solving sessions. Until then, I'll see you in my next video. Thank you.